settings. So coefficient of determination, you might remember as well, is quite heavily connected to our R value because the coefficient of determination is R squared, and how you calculate it is literally R squared. So once you have your correlation coefficient, you can actually take that number, you square it, and that gives you your coefficient of determination. And a word of warning here is no matter whether your R value is positive or negative, once you square it, it will always come out positive. Because if, for example, your R value is negative 0.7, to square it, you times negative 0.7 by negative 0.7. And we know that when we multiply a negative by a negative, that gives us a positive. So our coefficient of determination actually doesn't tell us whether our direction is positive or negative. We need to go back to our R value, our scatter plot, to figure that out, because a coefficient of determination will always come out positive. So a quick refresher, what actually is a coefficient of determination? It's the percent of the variation in the response variable explained by the variation in the explanatory variable. So coming back to my example earlier with like the car and like the kilometers traveled and the cost, if, for example, my coefficient of determination was, let's say, if, for example, it was 0.7, that would mean that 70% of the variation in the price of the car is explained by the variation in the kilometers traveled by the car. And that would imply that 30% of the variation in the price is accounted for by other factors. Again, because we're doing that bivariate data analysis, we're looking at the relationship between those two variables. We need to keep in mind that there are other factors that are also influencing that same response variable. So